Hey everybody, this is Chris here with the Energy Conservatory, and welcome to the webinar. Thanks for coming. Bill, do me a favor, hit that first icon. Span the screen the whole way. Up one, to the left, to the left. That'll work. Okay. All right, so we are inside the TEC lab. What have we been up to? If you've been following our newsletters and whatnot, you will see that this house behind me is our new test air house, right? It's our mad air house, is kind of what we jokingly call it. More to come on that, but this is all about TrueFlow, this webinar. Thanks for coming if you're here. We're going to talk a lot about new features and new capabilities, and we have been up to quite a bit with this tool and what it's capable of. Now, I have a lot of people showing up to this, a lot of people who are going to watch it afterwards and put it on our YouTube channel. That's where it's going to be. It's where it's going to live. And I want to make sure everybody comes up the same way, meaning I have people who own TrueFlows and are looking for those new features, new capabilities, and that's why they're here. I may have quite a few people who have never seen this tool before. So there's quite a few adjustments that have been recently made in the tool that affect the beginning part of the workflow. So we're going to start from ground zero and kind of work our way up, okay? Now, just to kind of, once again, ground the conversation of what are we doing here? So we're going to be talking about the Digital TrueFlow grid, right? And this is a total system airflow device. So it is grid, right? It goes in where the filter is located. You have an adapter plate that it's going to snap into, right? And that allows it to take the place of the filter. The adapter plate's purpose is to seal airflow where the bigger filter would have been that's bigger than the grid. So that's the point of the adapter plates that it snaps into. You'll notice that there's a light flashing on here. That's me powering this device down. If I hold the power button, it flashes green and then I'll let it go. And that is me powering the device back up. Okay, so quick little feature there while I'm talking about the tool that's in my hands. Just a quick note, let's pull up the comments. Is anybody having any trouble hearing me? I always like to ask that question to make sure that there's no issues. So give me some thumbs up if you are not having an issue catching my audio right now. All right, I'll keep an eye on that. Okay, so we just mentioned the grid. We have a gauge. So this is our DG8 gauge. So to run the TrueFlow, you need a manometer from TEC. Here's a DG8. If you don't have any of our tools and you're from the HVAC space, meaning you probably maybe don't have a blower door yet, don't have a duct blaster from us, I recommend getting into the TrueFlow kit with the least expensive gauge, which is our DG8. We do have DG1000s that run our blower doors and our duct blasters. If you have one of those gauges, getting into the Digital TrueFlow kit is essentially cheaper at that point because you already have the gauge. So the kit can work with the DG8 or the DG1000. So we're going to use the DG8 today. Okay. When you do get a kit, it will come with the tubing that you will need to connect to a manometer, right? And you'll get the static pressure port, which I had one and I've lost it. Will you grab one for me, Bill? Thanks. Bill's going to grab me a static pressure probe so I can use it on this air conditioner behind me to do some testing. All right, so to kind of show you what that looks like, you haven't seen one before, that is a static pressure probe, right? They've got some holes right here in it, and there's no hole on the end. So not like a pedostatic tube where you have a hole here and holes here and you're trying to get to velocity. This is just a static pressure probe, right? We're just measuring static pressure. So this is a lot less expensive than a pedostatic, and we don't need a pedostatic tube for what we're doing. We just need a static pressure probe. So, oh, look at that. There's one, just found it. How about that? Got two. Okay, any more things I need to ground you on before we keep going? Quickly, let's just talk about what's the purpose of the tool a little bit more and what are we going to do with it. So total system airflow. All right, so I want to measure total system airflow. Today I'm going to do it on this lab unit. Right now I have a furnace with an evaporator coil right on top, hooked to a very miniature duct system. Got a condenser. I'm not going to be running the condenser today because I don't have 230-volt power to it. Okay, so we've got a system behind me. We're going to run it. And what I want to know is total system airflow. Why do I want to know total system airflow? Well, if I was running it in cooling mode, I'd want a specific amount of moisture removal, latent capacity out of that coil, and I'd want a specific sensible capacity out of that coil, right? Both of those matter. And if you do a load calculation on a home and you do a manual S and you pick your piece of equipment, you go to your expanded performance chart, you can get to a design flow that's going to tell you what latent and sensible work you can get out of that evaporator coil. And so setting the airflow kind of coincides with that. That's how you're able to, set the airflow to get the capacities you're looking for out of that coil. They handshake, they go hand in hand. Flipping the script, going to heating mode, right? Heating is all sensible, but I want to set the airflow right on that furnace because I don't want a cracked heat exchanger that's going to come sooner than it needs to. I don't want to kill a fan motor, so I'm also watching pressure, right? So didn't quite get into this yet, but the tool's going to measure total system airflow. It's also going to be benchmarking pressures as we go through the workflow. That way, at the end of it, you can get a report. The report's going to show you not only the total pressure against that fan motor in the furnace, but it's also going to break down the pressures across different components, like the filter. How bad is the supply ductwork on this install? What's the return look like? All of that's going to be broken down with separate dials and instructions on what you can do to fix those if they're problematic. We're going to showcase that here in a minute. All right, so we've got our data set, right? We got our test end data, which I'll show you in a minute. Once we get that off the ground, we're going to go into forecasting. Now, forecasting's been out for a little while, and it wasn't fully complete. We had a big demand for forecasting in cool mode. Heat pumps have been a big push. We forecasted heat pumps. We've had even bigger requests from some of our clients who wanted it for furnaces, and we wanted to get there. So we've been working on it, and we finished that. Furnaces are difficult, and so we had to do quite a bit more app development work to get to furnaces, and that just got released. So I will be deep diving into furnaces and how we handle that in forecasting mode. That's going to be a big push of the day. Okay, that all being said, let's get into doing some real work. All right. So I didn't see the thumbs up, but I'm assuming people are still here, so they probably can hear me. If not, that'd be really weird to see me doing this with no audio. So thanks. All right, so jumping right into it, we're going to pull this tablet that I have right here up on the screen. All right, that worked on like the first time. Fantastic. Okay, so do me a favor, Bill. Oh, never mind. This one's on me. I should ground you and say, okay, this is my tablet. I have different little apps on there. You'll see that second one. That's the TrueFlow app. I wish my hand would cross over that screen, but I'd go behind it. But second icon, the TrueFlow app. You can download that on the Android or the iOS store. But that's the app we're going to open. When I say we're going to ground zero, we went all the way to ground zero. All right, so there's the app. When you download it, you're going to pop up. You're going to have a home screen. This is the home screen, okay? You have standard workflows, which are the workflows that we originally built that were distributed out to, the TEC audience. And they are system airflow and static pressure, which that's the workflow we're going to jump in today. That's the one that's going to require more work from you in the field. You're going to pressure map the whole system using that workflow. If you want all the data and you want the ability of forecasting mode, you have to use that top workflow right there, okay? Now, there's a system airflow workflow, there's a standard 310 workflow, and there's a pressure gauge that you can use. Now, those require less work and they give you less info, but those fit a certain need for certain individuals in the industry. Now, if I open up this menu and I expand it to the NCI workflows, NCI is a huge partner of ours, the National Comfort Institute, and they have specific workflows. So let me quickly talk to you about what those are. These are for the NCI members, people who go to NCI training. These are their workflows. And so the top one, the Air Max with TrueFlow, this one is very, very similar to that top workflow, system airflow and static pressure. I would say so similar that there's maybe not a whole lot of change in it just yet. Why did we differentiate them? Because if NCI wants something different, because how they teach their audience, we're going to change it, and we're going to change it in that workflow. Okay. Now the other two are pretty interesting. Meaning, let's say you're watching this and I don't have any gear yet. Let's say I have a manometer that's a different brand. I'm not ready to buy a TrueFlow, but I really want something that's going to educate me on how to take pressure mapping the right way. Where do I put the probe? That kind of advice. NCI convinced us it was a good idea to build an onboarding ramp, and that's what these workflows do. So the first one down below, static pressure screening, that is a workflow that lets you connect to any manometer. When I say connect, I mean you can put the measurements in manually. You can actually connect to other manometers. Our app will not connect to other manometers, just our manometers. But you can manually input the data. So if you want to use that and get into pressure mapping with your current manometer, that's a good workflow for that. Now, you won't get an airflow with that one. Jumping up, there's AirMax with fan table. And that workflow is you can use our manometer, you can use a different manometer, and then you will reference a fan curve chart. Okay, and so that's taking that one step further. We went from static pressures, now we're doing static pressures going to a fan curve chart. Because you know what? Using a fan curve chart may not be as accurate as a TrueFlow, but it's better than nothing. Okay, now we're going into the third one, right? Just to kind of recap on that. If you want a purity flow measurement, is what I like to call it. You hook to a TrueFlow and a manometer. At this point, you have to have one of our manometers to connect to. It works with only our manometers. So just a quick recap. There's two workflows that you have to have our manometer and the Digital TrueFlow with, and that is system airflow and static pressure, AirMax with TrueFlow. Those are the two. Those are the ones that are going to let you do the full workflow, get tested data, and then forecast future results on a new system or an edit to that system. Okay, so that is a grounding of all of the workflows we currently have in the app that you can use. Now, let's start off with system airflow and static pressure. I'm going to select that workflow. The next thing you're going to see on the screen is that we have hardware that we can connect to. It's got the model numbers, right? So DG835, if I go to my DG8 really at the top, I know you can't see this, but I'll read it out loud. It says DG835 right on the top screen. That's very useful for me because I'm at TEC and half the time I got 20 gauges living on that screen. So if I don't go look at the model number, I may be connecting to Eric's manometer while he's working on it in the lab in the electrical room. So, all right. So I select that plus. When I do that, that is the Bluetooth connection happening between my tablet and the gauge right now. So it's thinking, it's looking for it, it's tying, and it's like saying, okay, let me connect. All right. I'll do the same thing with the grid. Hit the plus there. All right, that one connected to my grid. Looks like I may have stumbled across a small glitch. So if this ever happens, what I do is I'll go to a different screen. Let me go back one, go forward one. Let's see. Why am I not getting my gauge back? Hang on. All right, real world live. Nothing like it. Yeah. All right. So software. Here we go. There's a bug. So let's oh, look at that. Eric's paying attention. My DG8 gauge turned off. Man, you can see that from there. It's super impressive. Thank you, Eric. So Eric caught me. So our gauge and our grid, if it's not connected to anything for extended time, it will just turn off because we don't want the batteries to run down. So I didn't see that, assuming it was on. Now we go back to the screen, we see we have them both. So thank you to the people in the chat who are very in tune right now. Okay, so we've connected to those devices. Now, because I was flipping around in screens, I'm at the device screen down below here. I want to back up for a second. I want to disconnect because I want to show you kind of a different way to do that. If I go back to the home screen, okay, and I pick that top workflow, it automatically advances me to the device screen. So don't think you have to go to the device screen and then see the devices connect and go back to the measure screen. It's part of the workflow, and I didn't quite show it that way because of that manometer being off. All right, so I'm connecting to the two devices. Okay, and now I'm gonna answer a couple questions. So today I've got this system jumped out running heating right now. I'm not actually running the heat because obviously I don't have a flue pipe on this system, but I've jumped out and faked it out and told it everything's fine. So the fan motor's running behind me. There may be a little wind noise. So we're in heating mode. So I'm gonna select heating, right? We have a furnace. These are big buttons, by the way. And I'm gonna say I have an upflow system. Those buttons are important because it's gonna paint a picture. You'll see that in a minute. All right, heating system details. In the app, if you're coming in from fossil furnace fuel heating, there's going to be details. If you come in from the cooling side of things, there's going to be details. The details change every time you make those selections on your way to this screen. So all you got to do is just fill them out, depending on what they are. And there may be a change or two here that's changed. So air filter location. We have filter grill. We have filter slot in the duct or the cabinet, and we have multiple filter grill. Okay. The only thing that's changed here quite recently, and I want to make sure I focus on this, is when I select filter grill, watch what happens in the screen. Boom. Okay. You'll see that a drop-down menu just appeared, and it says separate filter and return. It is required to view forecasted results. That is the app telling you this right here. I have a filter grill. Okay. When the app originally started, we didn't have forecasting. We had to separate the filter grill from the return ductwork to be able to forecast all of the results. To do that, we had to ask you to give us that pressure mapping part of the sequence. So you have to toggle that on, and we're going to add that pressure measurement to the next screen, which you'll see in a minute. Now, if that bugs you to turn that toggle on and you're like, I don't want to do that all the time, you can go into the settings down right here. And there's a toggle here that says always separate filter and return. If you toggle that on, you'll never see that again. It'll always live on, which means every time you pressure map, you take that extra pressure measurement, and you're going to be able to forecast the future install from the test in data. So just know there's a button in the back that can eliminate those choices. Makes life easier if you're one who always wants forecasting. Okay. External indoor cooling coil. What does that mean? That means that the system I'm testing has a coil that is after the furnace. The coil is external from the piece of equipment that has the blower in it. Okay. Now, I will tell you in a near future release, we plan to change that toggle to 2 images, furnace with a coil, furnace with no coil, to make that a little bit easier to understand. That's to come. That's on the improvement list. Okay. The next one is new. We've changed how furnace input data is entered on test in data. So let me jump into that. All right, I've selected furnace. Now we're going to enter furnace data. Now, that data is going to be found inside the furnace. So because I'm not trying to make this a 2-hour webinar, I went ahead and wrote that data on this piece of paper. So just hang with me. We're going to fill this out. So the first tab, we're going to name it. So we're going to start typing the word Daikin. You'll notice that we've kind of entered most of all the manufacturers into the list. So you just put DAI and Daikin pulled up first. Boom, we make that selection. Now we have model number entry. We're going to enter that. It's a DM80 SN 0403 AXAA. Okay. Rated input, it's a 40K furnace. The output is a 32,000. Now you'll notice AFUE is automatically calculating. So this is something we've added, we've changed a little bit, make things easier. Let's just say you can't find output, but you know AFUE. So obviously it's an 80% AFUE furnace. So let's just delete for a second the output. Let's say I just have the AFUE. You could put 80 and then output automatically calculates. Okay, so either way you want to do that. Now, this one has changed. This one's been a fun conversation at TEC and has came up to the table many times. When the app started, we put a default TESP, total external static pressure, okay? And so through the audience that had the tool, we got feedback, and there was quite a bit of deliberation that I was like, I want a super user feature that says, let me enter my own TESP. We got that. We won that one. Yay, go us. All right, so we had it. You toggled it on in the settings, and then you could set the total external static pressure of the system, okay? This is probably the hardest data input that you're gonna have to go find when you're putting in information for testing of cooling, heating, or anything, okay? So here's a switch that we've most recently made. It was becoming a challenge with programming, having to toggle it on, toggle it off, enter it, not enter it, do this, do that. So we said, okay, enough is enough. We're gonna put it in as a default, okay? Default, it's always there, always adjustable. That's how we're handling total external static pressure now, and we've defaulted to 0.8. So right now we have a default of 0.8. We can change it if we want to. We're gonna put 0.8. All right. I have to address this before we keep going because it's came up a lot and I want to make sure there's a resource for it. Inside this furnace, it has an input that says, here is the field tested external static pressure. Okay. If you've read that on the tag, that does not mean that that is the limit that that fan motor can run for this furnace. That just means that when it was tested in the lab, that is the pressure that they tested it at. That is the test pressure. SEER2, if you've heard SEER2 went up to 0.5, and 0.5 is like the rated static equipment gets tested at. So where do we get that static pressure measurement from? I just so happen to have right here the manual for the furnace behind me. So tag has 0.5 and it kind of alludes to rated. And there's a big confusion between rated and max TESP. So in this manual, it'll say heating mode speed selection. There's a note that says always refer to the heating chart to choose from available heating speeds, just so we're all clear. Okay, which is telling me that I should go to the fan curve chart. So if you want to know what you can get out of this fan motor to make it run, you got to go to a fan curve chart that's in the manual. Sometimes it's listed on the tag, sometimes it's not. It depends on the equipment. This is why TESP was very difficult for us to manage. We want people to enter what the max is that they can use. We didn't want to shortchange them. So, for example, I've highlighted the furnace that we have right here, okay? And here is the fan curve chart. And you'll notice in that row, it goes up to 0.8 inches of static in the heating airflow. So we can use 0.8 for our TESP limit on this because our fan curve chart told us we can, and that's what the instructions told us. Okay, so what is the difference? There is rated static and there's the blower curve chart. And when you hear max TESP, you want the limit of the blower curve chart. Okay, sometimes that's hard to find. 0.8 is the default. Why? It's the most common. That's why. Okay, conquered that. Let's keep going. On the tag, you'll see the rated temp rises, right? This is the temperature operating ranges of the furnace. So we're at 25 and 55, so we're going to slide the min to 25, and we're going to slide the max to 55. Okay, and that's going to help us set our colored dials that you're going to see later of what's acceptable to run this furnace at for temperature rise. All right. The next three selections are optional. You don't have to put them in. You could go to the next screen without it. But I am going to put them in. But if you don't want to, you can collapse that screen if you want to. You can open it back up. So first one's cabinet width. There's A, B, C, D, and an unknown, right? So A is 14.5. What are we asking for? The width of this furnace. So the width of this furnace is 14.5. You're probably asking, like, why go there, Chris? Why'd you do that? So in the long play of what we want to do with forecasting mode, when you select new equipment, we want to have a game played out where you can filter down the equipment to what's going to work. If you're in basement country and you have a vertical system, a lot of times there's a water heater right next to it and you're limited on space. There's a wall, there's a furnace, there's the water heater, and you have only so much space. So if you're selecting a piece of equipment, cabinet width is important. So let's say you're trying to pick between 3 and you have 2 14s and 1 17.5. Well, you may want to just eliminate that 17 altogether. Show me the 2 14.5-inch furnaces. That's part of a filtering game to come. All right, so gas valve, single stage, 2-stage, modulating, unknown. What we're doing there is kind of like helping filter systems, just like what we were doing with cabinet width. So it's a single stage gas. So we're going to click done. The next one is high altitude derate percentage. So derate, so as you take this furnace and you move it into high altitude situations, like Denver, Colorado, or going even higher to Breckenridge, the manual is going to say something about derating that furnace, and it's a percentage, and it is not the same across the board of all furnaces. I wish it would have been, because then we could have geotagged it and solved that problem for you. But I read a ton of manuals, and I found out that it's not always the same, which means it has to be a user input. So you got to go chase that data point down. If you're not in Denver, or anywhere around Denver, you're probably okay. So basically, leave it blank. Okay, we're going to click confirm. All right, so we've got our furnace details entered at this point. Last data endpoint on the detail screen is return air temperature. We're at 70 degrees. That's default. That's what shows up. Here's what I will tell you. I advise people, look and see what's on the thermostat, use that temperature, go with it. A little bit of temperature variation in that input is not going to change flow very drastically. Like if I put in 75 instead of 70, I'm not going to get 100 CFM swing in the measurement. I might get 2 CFM a swing. All right, so don't freak out. Don't pull out your meter, plug in a temperature probe, and start measuring flow right next to the furnace. That's not needed for that level of input for this. All right, I'm going to click next. Okay. At this point, we've entered all the information that we need to go to work, right? We've got all the information about the equipment we want to test baked into the app, and now we're at the pressure mapping screen. Now you'll notice there's two places to measure pressure at, one right after the filter and one that's a little close to the blower. I know we're working on size here, we got a small image there, but the idea is one pressure measurement is immediately right after the filter, and then one's closer to the blower. Okay, so, yep. I got to speed up, is what I'm being told by the big boss. All right. All right, we're going to put that pressure measurement in there for that first pressure. And we're going to click take measurement. Okay, as that line goes across the screen, we're capturing that pressure of the filter grill. All right, we got that. We're moving on to the second one. All right. Take that measurement. Obviously, you may be hearing the furnace trying to fire behind me. That's okay. Disregard that noise. I have the blower jumped out. We're still moving air. So, okay, we've got the second measurement. The third one is going to be right after this furnace, right before the coil. Now, while that's going across the screen, I'll say one quick thing. A lot of people will ask me, Chris, where should I drill that hole? I don't want to drill a hole in the coil. I always tell them, go in the furnace, go about halfway down, and go about 1 inch down and poke a hole. That's typically what I do. All right, now I'm down to my last pressure measurement. And I'm going to put that right in the supply plenum right here at the top, about 6 inches up from the coil. I'm not going to put it down here. Why am I not going to put it down here? Because that would be after takeoffs, right? If I'm getting rid of air, pressure is going to go down. That's not the full supply plenum pressure. I want to see all of it, which means I need to take a pressure before I have takeoffs. Oh, quick tip. If you have an air handler and you go in that first 6 inches and you're getting negative pressure for any reason, go further down another 6 inches, because you know those air handlers have a small exit. And if you're in the dead spot, if you put a plenum that swallows the whole top of the air handler, that first 6 inches right next to that, on the opposite side of that exit, you'll get a negative pressure. That's a whole nother conversation we're not prepared to go into today, but just know if you're getting that, move the probe, find the positive pressure and keep going. Okay, we've got our pressure mapping in normal system operation. We're going to click continue. And now we're going to measure flow. Okay, so at this point in time, that supply plenum pressure here does not move. It stays in its current location. What's going to change now is we're going to pull the filter out. All right, we're going to take out this 14 by 20, put it off to the side. We're going to take our TrueFlow grid and the adapter plate that's 14 by 20, and we're going to put it in the grill. Okay, we're going to leave the grill open, just like the wording says on the app. We're going to take a measurement. Okay, what's happening right now? We're taking a raw flow measurement across the grid. It's not the flow we want. I'm going to explain. Raw flow measurement, supply plenum pressure. We're taking a supply plenum pressure right now, and we took one when the filter was in. So we have 3 pieces of data that's really important to us right now. We have raw flow, we have pressure when the raw flow measurement's happening, and then we had pressure when the filter was in, okay? Because there's a resistance difference between the filter and the grid. All 3 of those pieces of information get calculated in the app to give you flow through the system when the filter was in place, not right now, okay? All right, so at this point in time, we've got a flow measurement. We're going to click continue, return system to normal operation. Okay, I will do that. I highly advise doing that when the app tells you to. Why? Because if you're a MeasureQuick user and you're looking for capacity in everything, because you're like TrueFlow is just an addition to using that app, when you've got temperature probes and everything else connected, if you leave the grid in at a different resistance, you're going to go back to MeasureQuick, and when you're seeing live streaming data, things aren't going to add up. So make sure you put the filter back in and get the resistance back to what it's supposed to be when you hop back to that other app coming from the TrueFlow, right? So that handshake is important, and it's important to put the system back to normal. So select OK. We're going to save it so the app automatically puts a time date stamp there. We're going to click save. Okay, now we have test in data, okay? So we're moving 136 CFM or SCFM. S stands for standard, standard cubic feet per minute, basically sea level conditions, okay? And then we have TESP. On this system here, TESP is before and after the blower, meaning after the filter grill, that second pressure measurement we took, which was down there, that's return side TESP. Before the coil and after the furnace is supply side TESP, right? Yeah, I hate to say, I shouldn't say add those 2 together. The delta between those 2 is TESP, okay? All right, and then like we talked about, we got return plenum pressure, which was really, really low. Filter pressure drop, which isn't too bad, right? We were 0.18, that's pretty good. Evaporator coil pressure drop is 0.128, so nearly no pressure drop across our coil, and our supply plenum pressure is pretty good. So this system appears to be very healthy, right? So if you were just taking TESP and didn't have flow, you might would think, man, this thing's it's healthy, right? But we have low flow. So the flow should be increased on this furnace right now. Okay. Now, let's get into, so basically, if you've never seen this tool before, you just got caught up. This is what we call the test in data. This is the commissioning data. Let's say system's already been installed, you're there to commission, you want all the data, boom, you got it, right? If you wanted to see more of that, you click report, add in the customer's information, address, you got it, you create report, there you go, okay? You can add pictures, you name it. Now, everybody's caught up, we're up to speed, and I'm gonna jump now into forecasting, which we're gonna show the improvements that are made there. So another button you see at the bottom is called forecasting. We're gonna select that button, and I'm gonna read this out because it's important. Forecasting details. TrueFlow Forecast provides predicted performance of new equipment or settings with the existing ductwork. TrueFlow app does not provide a load calculation to determine required equipment capacity. So what does forecasting do? Right, you're gonna have to select a capacity when you move forward in forecasting, which needs to come from your load calculation. But the forecasting is more about does this system work on the existing ductwork, right? So this is a big part of the retrofit game. You're going in, you're making box swaps, you're changing equipment out, and you got to evaluate that duct system. Is the duct system going to work? Is it not going to work? How many times, you got to ask yourself this question. How many times have you changed the system out on the existing ductwork, and then you only to find out that later that it's running high TESP, and now you got to do some duct work. You didn't discuss it in the beginning, and now a customer's like, wait, time out. You sold me a job, you put the system in, the system's having issues, and now you're telling me that I have to do, I don't know, $2,400 worth of duct work because of why? And that's what we're trying to avoid, right? We're trying to see those issues before they become your issues, because that's a really hard conversation to handle. And so would you like to know if that ductwork is going to be an issue? That's what we're here to do with forecasting. Okay, so we're going to click continue. We've got some options. So here's another big release that we just did. When forecasting came out, people were like, oh, it's really, really warm here, but I'm in a predominantly heating climate. I really want to forecast in heating mode. I don't really want to run the heat right now. It's hot in the house. It's not a good time to do that. And so we were like, yeah. So used to be you test in cool mode, test out in cool mode. We'd only let you go one way. We've changed that. Now you can forecast in cooling mode and you can forecast in heating mode no matter what the test in was, because we just use the test in as a benchmark. Okay, so that's helping a lot of people out. So there is a video. There's quite a few videos out there on the cooling forecast, so I'm not going to jump into that for the essence of time. What I'm going to go in today, which is what is brand new, which is some additions to heating mode. So we're going to forecast heating performance in heating mode, and you'll see that we now have 3 options. Originally, we had the heat pump, okay? So we've added electric replaced with resistance heat, okay? So I'll quickly jump into that. Resistance heat, we're gonna make that selection. We get asked, you know, are you putting back an air handler? Are you putting back an electric furnace with a downstream coil? Those are rare, but they're out there. That's why we asked that question. So let's just say we're going with an air handler. Here's that max TESP question, right? You're picking a new piece of equipment. We got to know the external static pressure of that new piece of equipment. That's how we set the colors on the dial. So we're going to default to 0.8. It's adjustable. We're going to select next. Now, here's that heating capacity question. This is a slider that's got to set that capacity. You have to go figure out that tonnage, and you got to set that tonnage. In this slider, we're making KW jumps, right? We start at 5 KW, go up to 6, 7, 8, 9, 10, right? And so on and so forth. Now we're going to slide that expected filter grill pressure drop. We'll just move it over wherever we want to go. Doesn't matter. Set it to what you think's right. Ideally, when you're forecasting, the mission of forecasting is to try to get those 2 dials at the top in the green. Get them in the green, you're probably going to have pretty good install. That's the mission. So the second slider is really important because that is filter grill pressure drop. That's a component you can change that doesn't change the capacity that you had to determine from the load. Ideally, you set the load, the heating capacity based on the load. Okay, like that is not something you should just adjust to get dials in the green. But you can do permanent load reduction work. Let's say you have this situation where you are here, right? You have high TESP, you set the capacity from the load, and you've already made a filter improvement to 0.1, and you're thinking, well, I can't make any more moves, Chris. Like, I mean, like I've already put in the best filter I could possibly find. Do I need to do duct work? Maybe that's the right answer. You go to see results, and you can see that supply plenum pressure is really, really bad. This job needs a supply ductwork overhaul. That is what the app's telling you. Now, let's go back. You could attack it in a different way. You could attack the house, bring the load down. That's another angle you could play. And if you do that, and let's just say you get to here, well, now the TESP is at 0.5. So, okay, now you got a system that could actually run. You got some dials in the yellow. We've got some recommendations for you to fix some supply. Do you necessarily have to? You don't have to because you brought the load down. So that's another way to go about it. All right, I'm going to jump all the way back to this screen right here, which is where we were talking about which way could we go in heating. And we're going to go into replace with fossil fuel furnace. Okay, this is where a lot of work got put down. So All right, we have a furnace with a coil, and we have a furnace with no coil. We're going to select furnace with coil. Okay, now you might have seen in electric heat, you selected capacity. If you've played with this app before in cool mode, you might have seen where you select tonnage. That is the first initial design of forecasting. And I like to sum it up as design it and go find it. Okay, and that's one way to go. Why did we do that? Because generally speaking, you know, like in cooling mode where it's CFM per ton, I know there's some slight variation, but generally speaking, you're going to move around about the same amount of airflow per ton and half ton as you're making a new piece of equipment selection. Furnaces, you can't do that. Furnaces kind of have a wide variety and a wide variety of selection, and things are radically different because they have different temp rises, right? If you have a very high efficient furnace, it may have a very low temp rise. If you have a old school furnace, which you're not going to get something really old, but let's say you got an 80% furnace, you could have a very high temp rise that's available to you, which means you can move a lot less airflow to make it work in the duct system. All that being said, we had to go with a different strategy. So instead of design and find, now the strategy is choose and use. Okay, so right now I have the existing furnace shown on the screen right there. I've entered the data of that furnace. If I select it, that's me saying I want to see that in the simulator. That's going to come next. You'll notice I have a carrier furnace in my custom furnace list. I have 3 Daikin furnaces shown in my Daikin list. Okay, I'm going to get into how that list comes alive here in a minute. Let's just go to the forecasting screen. So I'm going to just pick this furnace, I'm going to pick this furnace, and I'm going to pick this furnace. Why? I don't know why. It's just the 3 that I just want to select to take over to the forecasting screen. All right, I'm going to select, pause for a second. If you have a furnace at this point that you have not embedded into the app already, which we will talk about in a minute, you can add one right here, right now. And you have a button here that says add new furnace. And then it says, which list do you want to put it in? You could put it in the custom furnace list, which by default, custom furnace list is the default list. If you haven't created another list, that's where the furnace is going to go. So I'm going to select custom furnace. I would enter all the furnace info very much like you've seen me do on the test in for this system here. Same information every time. Enter it in, you're going to click confirm, and it's going to land right here in the custom furnace list. And now it lives there forever. And you can go back and select it anytime you want. All right, so we're going to click this furnace, and this furnace, just for fun. We're going to select continue, and now we're back at the simulator screen, but things look a little bit different. We do not have a capacity slider. Instead, we have radio buttons, and we have those 3 furnaces shown in radio buttons that you can select. So let's set a filter grill pressure drop here and a coil pressure drop here, because we can change the coil if we want to put a new one on it. And you'll see, okay, we have airflow TESP. Now let's just say we're going to use the same coil. Now, we're going to just move this all the way to the other side of the screen, because the evaporator coil pressure drop is pretty high when you start looking at flows for these new furnaces. So that's an issue, and I'm going to describe that in a minute. All right, let's say I optimize my filter. Right, instead over here, I'm going to bring it all back down to 0.1. Try to get the best filter I kind of can on this system within reason. Well, the existing furnace, you know, if we're looking at center of the temp rise, it wants to move for target flow 269 CFM for every 10,000 BTUs of output. Okay, so that's how that's being calculated for a total of 862 CFM. So we need more flow than we're getting right now. Okay, and so we can try to get our TESP to 0.738 if we can reach that target flow, leaving the same evaporator coil. Now, I can now go see how the rest of the system shakes out when I do that. Now I have the 4 pressure dials in front of me that show me the rest of the system after I tried to optimize the first 2 main dials that are the most important. Okay, and that being said, the evaporator coil is designed at 0.4. All right, because I designed it from the simulator. Our simulator screen here has a range, right? And we put a range to it because there's so many clicks of the button, it gets congested if we put too many dots. So I was like, well, let's put a healthy range on that. let me say this. What you're seeing right now in this installation is a coil that is probably not the right fit for this furnace. So we have a 40K furnace, 80% efficient, and we need to move more airflow, but we have a really high pressure drop because of this evaporator coil selection that's sitting on top of this furnace. So ideally, this is not a good matchup. That's what I'm learning. All right, so let's say we have different furnaces to choose from. So that furnace is not what we want. We just touch the second radio button. Boom, we go to this furnace. Okay, you'll see that the gray triangles have moved. Those are the benchmarks for the existing pieces of equipment at the new design flow for the next selected furnace. So we move that over to that triangle, and that's where that furnace lands out. We can then just select the third furnace, right? And obviously it's pretty close to the other one. But also one thing I want to show you. Let me go back and pick another furnace that I think has a 0.5 on it. I might just pick all of them, trying to find what I'm looking for here. Here's what I mean. I think I had designed one of these furnaces to have a 0.5 TESP instead of a 0.8 TESP. So pay attention to the far top right dial. Okay. So let's see. We're going to shake this out. So that one's about a 0.7. Let's see. Boom, 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 boom. Nope, didn't put one in there. All right, sorry about that. Okay, what am I trying to showcase for you right now? That total external static pressure dial where the green, yellow, and red land, when you change the TESP target that we've been talking about through the workflow, you will change where those colors land based on the input data. So that will happen inside the app. Sorry, should have baked in a furnace that had a lower TESP. I showed you that. Okay, so that's how we're handling forecasting for furnaces. Choose and use instead of design and find. Now, with the time I have left, right, let's jump into how do I bake in this data, right? So there's been quite a little bit of a learning curve here. Let me set the table of how we landed here. A friend of mine who has a large company has a lot of comfort sales technicians that work for him. And he's like, hey, it would be a whole lot easier to choose and use. And if you choose it and you use it and it works in the app, then you just send me the report and it has all the information of that furnace on the list. He's like, that'd be great. He goes, I really don't want them to have to design it and then go on this wild goose chase trying to find it. He's like, that's a little bit of a problem. And we were like, man, could we do that? And so that's what we've been working on is moving toward this choose and use strategy. That way, when you do this, you're done. You have the data you want baked into the report and you send it up the chain of command. It goes back to headquarters and they know exactly what the order from the distributor and take to the job. Nobody has to be a middleman that takes design measurements and says, okay, well, let me go now figure out which furnace could work for this. The furnaces are baked in. All right, that being said, this is how we handle that. Here on this screen, what you'll see is new is a title that says Manage Furnace List. And it lives right under the subtitle that says Manage Data. So select Manage Furnace List. Okay, there's quite a few little different functions going on here. Why do we do it that way? We wanted to make it really flexible. We wanted it to work for the really big company. We wanted it to work for the smaller guys. And we were like, how do we make this to where everybody can benefit and kind of make it work for them? So at the top of the screen, you'll see there's a trash can. There's another button that says you can name a new list or share a list. And then the second tab says, we've got a little plus with a little list, and it says you can create a new list or import a list. Okay, so if you want to add, share, delete, all of that takes place from the buttons up top. Now, going down one tier level down, I have in my list, I have custom furnaces. And for now, I've just kind of put in two equipment manufacturers just to kind of show you what's possible. So I have Daikin. I baked in 3 Daikin furnaces. I put in Rheem. I have 3 Rheem furnaces just kind of baked in. Now, let's say I go to work for somebody and my owner is a Daikin dealer, and that's all they sell. Okay. And so I'm only allowed to choose Daikin furnaces for forecasting and replacement. But I want to see more for, I don't know, let's say, well, we won't get into that. Let's just say I want to see Daikin furnaces. Then what you could do is you could go to the ream list. You see where it says enabled. You could toggle it on or toggle it off. If you toggle it off, meaning you turn the enabled button to off, when you go through forecasting, you will not see the ream furnaces show up. I'll take you for a quick tour just so you'll know what I'm talking about. I'll also turn off the custom furnaces. Okay. So going back to a save test, let's go back to the one we did earlier, this one here. If I go to forecasting that, right, I read my details, I get here and I said I want to forecast a furnace and coil. You'll notice I have my existing furnace and I have my Daikin furnaces, and that's it. That's all I'm allowed to see. If you want to see more to that, you go into the settings. You can enable the custom furnaces. You can go to your ream furnaces. You can toggle that on. Click done. Go back to that save test, and now boom. Now I have all of my furnaces visible in the app, right? And so they're all indexed alphabetically, and you can see them all that way. Okay, so that is how we manage the furnace listings in the app. With the time I have left, my associate Bill Graber here is going to look at the comments and tell me if there's any questions that you guys want answered about how we're managing that. I will also add real quick, if there's something that you see that could make this better, obviously we're listening, we're absorbing, we're editing and making things better every day, and we love the feedback. We would have not gotten here if it wasn't for a certain someone. Okay, so if you want to be that someone for the next improvement, throw it at me, and we add it to the list, and improvements will come your way. So the tool is what you will make it. Everything we do gets based off industry feedback. All right, with that being said, let's see if we have any questions we need to get answered. Let's see, oh, very good question. Okay. The question is, can a list be shared with a user? So let's get into a couple things. Obviously, it seems like managing the list is very important. I would 100% agree. So let me tell a story. If I am a company owner and I have a certain list of furnaces that I want to have everybody who works for me have in their app, this is currently how we will do it. We could go to custom furnace list. Right now we have this carrier with a model number that doesn't make sense because I just kind of entered something so you could see it. I could add another furnace. Let's just say it is a, I don't know, Franklin. Let's just put a random model number, right? Let's just put, I'm just putting some data so I can get a listing up there and you can see it. I'll do AFUE, we'll do an 80%er, we'll do default TSP of 0.8. All right, we'll just save it. All right, so those are the two furnaces. Now, obviously, there'd be way more than that. But let's say those are the furnaces that I want everybody in my company using or selling. Once you bake it in one app, it can be ported out to everybody else's app through what's called a JSON file. So meaning, if you click the button here, you're going to, give me a second. No, yeah. This button here, the one that's got the 3 dots, the share button, we're going to name this list. We'll say, we'll call it share, right? And select OK. And then we're going to save that list to our tablet somewhere. I'll save it to files. I don't think I want everybody to know what's on my tablet. So I'm just going to, I'll just save it under downloads. I don't know. Okay, so we save it. So we save it as a JSON file. It's baked into a file, right? That file, put it wherever you want it. Now, at that point, you email that file out to anybody you want having it. You email it to their smart device, whether it be a phone or a tablet. They are then going to take that file and pull it in. Once they save it into their file folder, they're going to hit the button that's in the top right, and it says create new list or import a list. They're going to select import a list, and it's going to say, okay, direct me where you want me to go. Well, there just so happens to be a furnace list that says share. Boom, let me click that. Okay, now I have a new list that just arrived in my tablet. It says share, not custom furnaces, share, right? That just got sent to me, and there they are. That is now a list that I know that the company owner wants me to use when I forecast new equipment for the sale. So ideally, what I would do now is I would go to these lists, right? And I would turn them all off. And I would turn the share list on. And now that's all I can pick from in the workflow, just from the shared furnaces that I'm expected to use. All right. So that's how we handle the push and pull of data. More to come on that, I'm sure. All right.
There's another question, Chris, about.
I wanted to add to that just real quickly. You can also edit a furnace straight from managed list, right? So let's say this Franklin furnace is like, oh, there's something wrong here. If I, in the managed furnace list part of the app, if I select that furnace, I can go right in and say, oh, you know what? The TESP on this thing, it's actually 0.5. There we go. Let me confirm that. Let me save that. Now that furnace data has been entered, it's been changed. Of course, the little trash can right there will let you delete it if you don't want it on the list. Delete it, gone, right? And that's going to change how it looks in the workflow, right? Now that furnace is just not even there anymore. Okay, so that's a little bit more about how we push, pull, and change and edit data.
So Chris, take a look at this one from Doug. And I think this might be where you talk about.
Can you move it off there so I can read it?
Oh, it's at the bottom.
Oh, I'm sorry. Will you collect equipment data from everyone's app and have a shareable database? Good question, Doug.
But we're talking about building some set databases.
Yes. So we're exploring a lot of thought on that front. First off, what we see as a powerful feature is trying to get pre-made lists that we host somewhere. Now, that's challenging, right? Because you get data goes out of date, equipment gets changed, edited, new equipment comes out, right? There's this ever-going problem with equipment data, right? So what we would love to have happen for any of the equipment manufacturers out there who may be watching, we would love to get a data connection going with you where if you produce equipment, we could see that equipment and we could see the expanded performance data of that equipment and we could put it in the app. And that way it's kind of like a hands-off thing. Everything's being updated automatically and it's considered a certified list. And we in the app could make sure that that list has an icon that says that's certified list that came straight from the manufacturer. That's a hope and a dream that we have that we would like to get to one day. So if you're an equipment manufacturer, help us out.
Last question.
Okay. Are we only given the option to forecast for the middle of the rated rise? Any plans to give us more flow design control? Excellent question. We were just talking about actually that this morning. So here's what I'll tell you for now. If you're in the middle of the green, left of the green, right of the green, you're in the green. You're safe, right? There's a no issue. You're not going to get any faults. There is a little bit of buffer room built into the color dials to make sure you're safe and you're not going to like harm the furnace. We don't want you on the fringe of the temp rise, okay? So if you're in the green, you're good. I think what you're looking for is like, hey, I want to enter design flow. So that is something we could do. I have been talking about that actually with Steve Rogers on the air conditioning side of things. And let's just say good feedback, more to come. Potentially, yeah. I don't see why we can't have more exploration on how we want to handle that. So keep the feedback coming. We'll keep the editing going. We'll, keep the options alive. But right now, I guess to answer that question is, don't worry about being in the center of the green as like, oh, you're a failure if you're not in the center of the green, right? Like if you're in the green, you're good. Okay. All right. Well, thanks for coming. That's the webinar. We hope you like the new features. I'm looking forward to the feedback. I have imagined there's going to be quite a bit, just like with anything, when you enhance it and you make it way better and there's more functionality, people have really creative ideas and they want to share them with you. And I want to hear them because I want to go in and I want to make it even better. So help me help you, and let's do it. All right. Thanks for coming.